Hi friends, welcome back. Today we are going to solve one very important, conceptually important and hard coding question on Leetcode 502 IPO, which is initial public offering. So as you can see from the like and dislike ratio, this is a very likable problem, and conceptually it's quite important problem to solve, and that's why it is a hard problem. So we will go through the problem statement. We'll understand this problem with a few examples, and then we will implement the Java solution for this problem in today's session. If you are new to my channel, I just want to mention that my channel is dedicated to help people in their Java J2E and coding interviews. On my channel, you will find lots of helpful videos that can help you in your interview preparation, such as there are more than 400 different varieties of videos, which are the coding questions previously asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big tech companies. Those questions are solved and explained using whiteboarding session examples for your easier grasping and understanding of different concepts. So if you are preparing for any Java J2 interviews or coding interviews, this channel will definitely help you in your interview preparation. So please subscribe to the channel now. So let's start this interesting and important coding question, a hard coding question on Leetcode 502 IPO. So suppose Leetcode will start its IPO soon. In order to sell good price of its shares to venture capital, Leetcode would like to work on some projects to increase its capital before the IPO. Since it is limited on resources, it can only finish at most K distinct projects before the IPO. Help Leetcode design the best way to maximize its total capital after finishing at most K distinct projects. So far it's pretty clear, right? The description. So you are given n projects where ith project has a pure profits I, and a minimum capital of capital I is needed to start that project. Okay, so they will be giving us two arrays. One is profits, one is capital, right? Initially, you will have a W capital which is available initially. When you finish a project, you will obtain its pure profit, and the profit will be added to your total capital. Pick a list of at most K distinct projects from given projects to maximize your final capital and return final maximized capital. The answer is guaranteed to fit a 32-bit signed integer. So the problem statement is pretty clear. So there is nothing like confusing or anything. They are going to give us the four things, right? K, which means that, for example, in this first example, right? K means maximum number of projects that we can finish basically, right? The W is the starting capital that we have, and profits is the profit for each project, and the capital is the corresponding capital required to start that project, right? So that's all the things they are going to give us. So let's quickly go through the constraints. So k will be between 1 and 10 raised to 5. W is between 0 and 10 raised to 9 inclusive. Profits dot length and capital dot length. So both these arrays length can be n, and n can range between 1 to 10 raised to 5 inclusive. So if the maximum we take 10 raised to 5, it is pretty big array basically, right? So profits and capital arrays can both will be pretty big. So we have to make sure that the solution we are going to implement should take care of that big arrays basically, right? So it should be efficient solution. So after that, the let's go here. So profits I means the profit value can be between 0 to 10 raised to 4, right, inclusive, and capital value will be 0 to 10 raised to 9 inclusive. So constants are pretty clear. So they have given us these two examples, but I created more like a bigger examples for our explanation, so you will easily understand the the concept that we are going to use to solve this problem. So let's go to the first example here. So this is the example that I created for the so I can explain you this problem, right? So k is equal to 4 means 4 maximum projects we can finish basically, right? The initial capital we have is 0, and these are our profits and capital arrays, correct? So let us first just visually solve this problem, and then we will go and solve this problem using our the logic that I am going to explain you in a minute, right? So maximum profit, how we can bring? So with this 0, so 0 is our initial capital. So what project we can do in 0? These two projects we can do basically, right? With 0 cost. Why? Because 0 capital means these two projects we are allowed to start. Correct? They have already given us in the example here or in the problem that this is the minimum capital of capital I is needed to start the project, right? So if our capital is 0, then these two projects we can start. So let's say we are starting this second project, right? So if we start the second project, our capital will become now 5, right? So we will get a 5 profit after we finish this project. So now we will have 5 capital. Now if we have 5 capital, then what projects can we start now? So we can actually start all these remaining projects with our 5 capital now, right? So all these remaining projects, so what are remaining? This and this one also is a remaining now, right? Because we have not done this project. So all these projects can be doable with our capital 5. Why? Because all this capital, as you can see, 0, then 1 2 4 5, so these are less than or equal to 5, right? So all these projects can be done basically with that capital. So let's choose then, so obviously what we should choose, we should choose a project which will give us the maximum profit, right? Because that is what our goal is, to maximize the profit or maximize the capital, correct? So which one we should choose? This one we should choose, correct? This one we should choose, because this is the maximum profit project now, right? So let's say if we are choosing this project, then we will get additional 40 profit here, right? So 40 profit means now our profit will become 45 now. This is, let's say, 45 money is available after we finish this project. How many projects did we finish? 2 projects we finished as of now, right? This is the first project that we finished, and this is the second project that we finished. So 2 projects we finished as of now, right? So 2 more we can finish basically, because our allowable limit is 4 here, right? So 2 more projects we can finish. So which projects we should choose? We should always choose a project that will give us maximum profit. So what is the next project that is going to give us maximum profit? This one, right? So we should choose this project now next, correct? So next this one, so 30 profit will be added to this. So now the profit will become 75 total, correct? Since we have chosen this one, right? Now still our projects are now from 2 to 3, still we have one more bandwidth to take one more project. Why? Because our k is 4, so we are allowed to take 4 projects. So now again we will use the same strategy of choosing a project that will give us the maximum profit in the projects that are allowable, that we are allowed to do. So all these projects are now we are allowed to do basically, right? That we have not done yet. So now which one we should choose? We should choose this, correct? Because this is going to give us the maximum profit, 20. So after we get this 20 profit, our total project is 4, and our total profit we made is 95 now, correct? Because 75 plus 20 is 95. So I just have this stack trace here. So this is how we should pick up the projects, right? So obviously from this we just went through this example visually, and we just picked up the projects that will give us the that we can choose to maximize our profit, right? So as you can see, which data structure we should use to solve this problem? So we should use priority queue, right? Priority queue we should use. And why we should use priority queue? Because priority queue is the max or min heap implementation in Java, right? So whenever we wanted to keep the elements in a sorted order, either minimum order or maximum order, then priority queue will be really helpful data structure in Java. So we will be using priority queue. So I'll just remove all these colors. Now you got the idea how we can solve this problem, right? So we'll be using priority queue to solve this problem, right? So PQ, right? Priority queue. And this is one very important data structure one should know, if you are preparing for any coding interviews, right? So how we can use priority queue? So let's again go through this example, and I'll explain you how we can use the priority queue, right? So we will need two different priority queues. One is for profits, right? So let's say we have one priority queue, let's call it as a profits PQ, correct? And how this priority queue we want to always keep the maximum profits elements on the top, right? So this is kind of a max heap, right? And the other priority queue we will need is the capital priority queue, right? Capital priority queue is the another priority queue we will need. So I'll just write it down here. So now how about capital priority queue? How should it be basically? So it should give like we wanted to keep all the projects with minimum capital in the beginning, right? Because that is how we want to choose the projects, right? The minimum capital project should be in the top in priority queue. So this is a min heap, right? So this profits PQ is a max heap, capital PQ is a min heap, right? So clear so far, right? So now let's start going through this example now. So let's say we have these two PQs we created. I'll just write down here. I'll just write like this is, let's say, one priority queue for profits, and we have another priority queue here, and this priority queue is for capital, right? So in capital priority queue, what we will do is we will go through all this array, capital array, and we will actually put the index of the capital in sorted order, right? So sorted order index. So what it means is basically you can have like this, like 0, then 1, right? Then this 1 means 2 comma 3, right? 2 comma 3. So like this we will put all the indexes, right? 2 comma 3, then this one is 4 comma 5, right? So 4, then 5. So this is how it will go basically, right? Then 6 7 8 9, right? So 1 2 3 4 5 6 7 8 9 10. So total 10 elements are there. So 0 1 2 3 4 5 6 7 8 9 10, right? 8 9, total 10 elements, right? So as you can see, 0 is on the front, which is the minimum value element, right? 0, the value of 0th element is 0, so minimum value element is on the front basically, right? Like this. So this is min heap, right? That's what it is, a min heap implementation, correct? That we will use. And this one we will use profits queue as a max heap, right? So maximum profit we wanted to keep it in the beginning of the queue, right? So whenever we take out or whenever we pull or remove the element from profits queue, we should get the maximum profit, correct? Because that is what our goal is, to maximize the profit, right? So now let's go ahead with this example. So now we already have the capital, right? So now what we wanted to do is we have the initial value of our W, right? So initial value of our W is 0, right? So we wanted to check what projects can be done basically with this 0 capital, right? So when we will go through this capital, and we will pull the elements which are having the value like less than or equal to that value basically, like less than equal to 0, right? So z means less than equal to W, right? W value is 0. So what are less than equal to 0? These two elements are less than equal to 0, correct? So these two elements are less than equal to 0. So which we will take the values of profits, and we will add these values into the priority queue. So these are the two values we are going to add into priority queue now, right? Because corresponding to this 0 0 index, the values of profits is 1 comma 5, right? So let's say we added these values into the priority queue. So you can just assume that we added, let's say, 5 here and 1 here, right? For corresponding, because these two projects can be done with 0 initial capital now, or initial capital, correct? So now how we will do it, like next thing is we wanted to pull the from the priority queue profits the maximum value, right? So maximum value, when we pull, we will get 5, right? Because this is a max heap, so we'll get 5. Once we get 5, our capital this capital will increase, right? So once we get 5, our capital will increase to 5, right? We will add that 5 into this W value. Now after that one is done, next thing we wanted to do is we wanted to now again go through it, the like remaining projects that can be done with this 5 capital, right? So how we will go it? We will keep polling values from capital PQ until for all the projects that can be done with capital 5, right? So what projects now we will get? We will get all these values basically, correct? Because all these values are less than or equal to 5, right? 1 1 2 2 4 4 5 5, all are less than equal to 5, means all these projects can be done basically with starting capital 5, right? So that's why we will get all these elements out of the capital in a sorted order. So which means that first we will get 2, then we will get 3, then 4, like that, right? Means the minimum value will get first, then 1 this, then 1, then 2 2 4 4 5 5, like this, right? Because capital is a min heap, right? So minimum value will get first. So as we keep getting these values, we will keep adding these corresponding profits into our profits PQ, right? So these are our corresponding profits, right? So now what we will now add? So after we add all these values, how our profits Q will look like? Let me show you that. So now our this 5 and 1 will be so 5 is already we already used, right? So this one, it will go at the end now, right? Because all the elements like will be kind of more, right? So one, let's put this at the end. Now what will be on the beginning? 40 will be on the beginning, correct? Because that is the maximum value. Then 30 will be there, right? Next value. Then 20 will be there, right? Next value. After that 15, correct? Because it is like maximum values in a descending order, right? Maximum will be ahead basically. So after 15 there are 4 ones, right? 1 1 1 1. So we have to put that 4 ones here, 1 1 1 and 1, right? And this is carried over from the beginning basically, correct? So this is how our priority queue looks like now. So how many projects did we finish? We finished one project as of now, right? So let's say projects we finished as of now is 1, correct? Now we have ability to finish 3 more projects. So it means that we will keep polling the values uh, for 3 more projects. So what values we will poll now? We will be polling these values, right? 40 we will poll, then 30 and then 20, correct? So as we keep polling, we will keep incrementing our capital, right? So 40 means our capital will become 5 plus 40, which is 45, correct? Once we poll the value 30, it will be added to 45, so now it will become 75, right? After that 20, once we poll it from the profits queue, we will add it to 75. Now the total capital will become 95, right? And the total projects we have finished now is 4, right? So now we have to stop because we cannot finish any more projects because K is 4. So this is the way we can assure that we will get maximum profit basically, right? So and that maximum profit value we have to return. So 95 should be the answer for this question basically, correct? So as you can see, I just put like the stack trace, how the W value keep increasing, right? So 5, then 45, then 75, then 95, correct? 95 is the answer. So I think with this detailed explanation, it's pretty clear how we can use capital priority queue and profits priority queue. So capital priority queue will be the min heap and profits priority queue will be the max heap, right? So this is pretty clear. We will test out these examples when we like run our Java code. But before we go to the Java code and Java solution, I just wanted to mention that another example I created, which is a little bit different than this one. So let's take a look at the another example. So now it is little bit different. Still we have 4 projects and 0 is our starting capital, but our projects profits is different here, correct? So let us just go through this example quickly. So you know, it will you will be more clear. So again we will have two priority queues, right? Capital priority queue, right? Capital priority queue is first one. This is the min heap, and profits priority queue is our max heap, right? Profits priority queue. So we will start with 0 capital now. Our number of project now W is 0 in the beginning, correct? Now what projects can we do? We will get it like first basically before we start doing that, we are actually going to go through this capital array and we are going to put indexes into our capital priority queue, correct? So let's say this is our capital priority queue. So we'll add all these indexes, right? So now this is already sorted. So how will the indexes look like? So like 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 values. So the indexes will go from 0 to 11, right? Because 0 based index like this, 3 4, then 5 6 7 8 9 10 and 11, right? And why it is like this? Because we are using min heap, right? So minimum value is 0, then 0, so that's why the index 0 and 1 will come first. After that 1 1 means index 2 3 will come, and so on, right? So this is the min heap. Now let's say this is our profits priority queue, right? So what project can we start basically? So we can start these two projects with zero capital, right? So we will add this 4 and 1 into priority queue, correct? In the beginning, 4 and 1 we added. So once we add that, we wanted to do one project first, right? So which project we will do? We'll do this 4 project. So once we do that 4 project, correct, we will just increment our W to 4. Now our capital became 4 and 1 is remaining, so that 1 will go here basically. So I'm just putting this 1 here, right? Because we did not do that project yet. So I just added it at the end. Now with this 4 value, what projects can we do with this 4 value? So let me show you. So these are the other remaining projects that our capital become 4, these are the projects that are we are available to take, right? 1 1 2 2 3 3 4 4, and this one is also available, right? We have not done that project yet. So we will again put these values into the priority queue, correct? So how priority queue will look like? First we will take the maximum, right? 30, then 20, then 15, right? Then 10, then 1 1 1 1, correct? 1 1 1 1, 4 ones, like this, and this is the carried on from the first one, correct? So now we have done only one project, right? So we have still ability to complete 3 more projects. So let's keep going. So now what project we will do now? Next we will do this project, right? Because this will give us maximum profit. So if we do this project 30, then our profit will total become 34, right? 3 plus 4, 30 plus 4 is 34, correct? So after that, once our profit becomes 34, it means that we are also now these projects will also be available for us to do, correct? Because it only needs 5 capital. Now our capital is 34, which is more than 5, right? So we can add 8 and 40 into our priority queue. So 30 we have done, so I will just add 40 here, correct? 40 I will add here because this is the maximum, and 8 we should put 8 here, right? In the middle I'll just write down here, the 8 will go here, right? And why we are doing this? Because it is a priority queue max heap implementation, so which means that the values will be in a descending order, correct? So now we have done 2 projects, correct? Now we have still ability to do 2 more projects. So let's choose the next one. So next one we'll choose is this one from priority queue for profits, right? 40, then 40 we have to add in 34, so it becomes 74 here, correct? So total projects we have done is 3 now, correct? So now after that, next project we can do is 20, right? Because 20 is the next maximum. So 74 plus 20 becomes 94, right? Now total projects we have finished is 4. So 4 projects we have finished. 94 is the maximum profit we can do basically, correct? By finishing these projects. So we have to output 94 as our answer, right? So with these 2 examples, it's pretty clear to you how we can use the priority queue to solve this hard Leetcode problem 502 IPO, which is initial public offering. So before we start looking into the Java code, this is the priority queue documentation from Oracle. So you can go through it. But here is one important thing. So like the time complexity when we are enqueuing or dequeuing, right? Like when we are adding something into priority queue, or when we are removing something from priority queue, the time complexity, as you can see, is log of n, right? So we will use that when we define our time complexity for our Java solution, correct? So this is the priority queue class. It's in java.util package. You can take a look later, right? So let's go ahead and let's discuss our Java part now. um, so this is our Java function that we are implementing. Find maximum capital. These four things are given to us, right? KW, profits and capital array. So first thing is we will just do the normal check. The profits, if it is null or profits length is 0, then we just want to return W, correct? This is the first basic check we will do. After that we will calculate the length of the profits array as n. Then we will create two priority queues, correct? First is the min heap for capital Q. This is our min heap, right? So basically the values will be in ascending order here, right? So minimum value will be on the top of priority queue, and the other priority queue we will create. So we are just actually implementing this through comparator, right? So this is what the comparator look like, correct? So this will make sure that the capital values that are going to be stored in this priority queue will be in ascending order. So which means that whenever we remove any value from this capital min capital queue, we will always get the minimum capital value, right? So this one is another priority queue we are going to define is for the max profit queue, right? And this is opposite. Now this is a max heap implementation, right? Which means that maximum profit will be kept on the top. So whenever we remove any element from this max priority profit queue, we will get the maximum profit value. This is again we are implementing through a comparator, correct? So as you can see, this is opposite to this, right? Here we are doing profits B minus profits A, right? So it is a max heap. So that's it. Then first thing we wanted to do is we wanted to go through the capital array, this capital array, and we wanted to add the indexes of the capital into the min capital, right? So we are adding the indexes, right? So no need to sort because this is already will take care of the minimum values of the capital here, correct? So now this is our min capital queue is populated. Now we will go through, like now we are going to choose the k projects, right? So that's why our for loop will go from 0 to k, correct? Means less than k means total k projects we are choosing. So what we are doing here is put all the projects that can be started to max profit. So if you look at this, so we are checking if the min capital queue, it should not be empty, right? It should not be empty, and the capital values in the array that we are going to use the min capital peak, right? So when we are doing the peak, it will always give us the minimum index, correct? Minimum index it will give us basically, because this is a min heap implementation. So which means that we will always go through minimum values, right? Like for example here we will first go through this 0 0 value we will get, right? Minimum value, right? And then we will add the values into the profit queue, right? Max profit queue. So why we are doing only 0 0? Because our capital, this value capital is 0, right? So only we can take this 0 0 2 projects, right? With 0 value. That's what we are doing. So that's what we are simulating. So we are adding what projects we can take with this current capital basically, correct? That projects we are adding into the max profit queue. After that we are checking if the max profit queue is empty. If it is empty, then it means that nothing is there basically to process in the profit. Then we have to just break out of that for loop if that happens, right? Otherwise we have to add our maximum profit that we can do in this project into our W value, correct? So that's what we are doing. So max profit queue poll will give us the maximum profit from that profits array, and we will add that into W value, correct? This poll will give us the maximum profit. This whole thing will give us the maximum profit, and we will add into W, right? But maximum profit, what I mean to say is maximum profit of the project that can be doable basically with the W value, right? That can be doable, right? Because it might not have the projects which are outside of the W range, right? So what I mean to say is this second example that we saw, correct? Let me just show you this. So what I mean to say is, let's say in the beginning we can do this 2, correct, with the 0 w, right? So with the w0 we can do this 2. Let's say we are doing this maximum 4. Now our w will become 4, right? So which means that these additional values we have added, into our priority queue, right, for profits, right? But there are, so only these values we are considering basically, correct? So these two values we are not considering because that is out of range. 5 is out of range for us. We cannot do these projects as of now, correct? So that's what we are doing here, right? So we will keep incrementing the w. This just to print out, we can remove that. So we will basically go into this for loop, and this way we will uh, try to maximize our profit, right? And at the end we have to just return w, which is the maximum profit. So this is the pretty much it, like the code. So the time complexity is n log n here, correct? And why it is n log n? Because as I shown you in the Oracle documentation of priority queue, when we are adding something or removing something into priority queue, it is a log n, right? So we are, if we have n elements total here in profits and n elements in capital, we are doing it like adding it, let's say 2 times, right? So n log n 2 times. So 2 times we don't consider when we are talking about the algorithm complexity, right? So it is considered as n log n time basically is the complexity of this solution, time complexity. How about the space complexity? How much space we are using, right? So let's say profits array and capital array has n elements, right? Then we wanted to put those n elements. Basically we will need priority queue to hold those elements. So 2 times n space will be needed basically, right? So 2 times n means we don't consider that 2 factor here, right? So we just remove the 2 and we just say that the space complexity will be n for this solution, right? So that's what it means. So let's go ahead and execute our these test cases that I shown you here. So first example, let's take the first example. We are expecting 95 as our answer. So I just created this first example. Let's run this example quickly. So as you can see, 95 is the correct answer, which is accepted. And this std out is just to show you that how the profit gets calculated, right? 5, 45, 75, 95. So like this here, right? So this is the profit. So that's what we are just printing. So let's also make sure that we are executing this another test case that we discussed. So 95 should be the answer for this. So let me just copy that example that I created so I can just execute it for you here. So now we will just change the example here, the test case. So this is the second test case we discuss now, right? So let's make sure it also gives us 94 now. So 94 is the correct answer we are getting. So as you can see, W values goes from 434, 74, 94. Here also 434, 74, 94. We have seen that already in this example, right? I just removed that coloring thing. So now we will just test out all their example test cases and make sure everything works. But we will just remove the system out. We don't need that. So 4, 6, 4, 6. So we are getting correct answers, right? So we can just go ahead and submit our solution now and make sure our solution get accepted by Leetcode. So our solution got accepted by Leetcode. It is almost 81% faster than other Java online submissions and 90 to 99.62% better than other submissions on memory usage, which is a very good solution for this problem. So this is the way you can solve this hard problem on Leetcode 502 IPO, initial public offering problem. As you can see, it's quite likable problem and many times asked in the interview questions, similar problems like this. So make sure you practice these kind of problems. So the important concept they are going to be testing here is you should know the priority queue here, right, to solve this problem, and you should know how the min heap and max heap implementation works, correct? So with the help of priority queues, we can do the maximization of the capital, right? If you are new to my channel, on my channel there is a dedicated playlist called as Leetcode and Leetcode solutions that has over 250 different varieties of solved problems explained with whiteboarding session examples and Java code. And those are the coding questions previously asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big tech companies. So apart from that, if you still want to practice more coding questions, then I have three other playlists on my channel, namely Code Forces, Code Chef, and Ad Coder. All in all, you will get more than 400 different varieties of problems that are solved, explained using whiteboarding sessions, as we did in this case, with examples and the Java code. Java code is always shared in the GitHub project, and links are shared in the description for your so you can practice those solutions, you can understand those solutions and play with the solutions with different test cases for your better understanding. So if you like this video, if you find this video helpful, and if this video help you in understanding this hard problem in an easier and better way, then please give it a like to the video and give it a thumbs up to the video. Also share this video as much as you can with your friends and colleagues, so they can also benefit by watching these videos and they can also get help during their preparation. Subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of the channel is to help as many people as possible in their coding problem solving by showing and demonstrating them how different varieties of problems can be solved with the help of different data structures and Java and different techniques. So they can also learn different techniques from these videos, and it can help them in their interview process. So if you like this video, please give it a like, share it as many times as you can. I often keep posting videos of important problems from coding interview perspective, as well as Java J2E related coding interview material that can help Java J2E interview preparers. So hit on the bell notification icon so you will not miss any important videos in future. And the Java solution that I'm implemented in this session, this solution, I'm going to share this solution with you in my GitHub project, and I'll give you the link so you can check it out from there and practice the code. If you like my Java solutions, please consider giving it a star to the GitHub project. That would be great. And to become more and more confident in your coding interviews, keep practicing different varieties of problems and keep using different techniques to solve the problems. Then you will become more and more confident and in your coding interviews. And one simple tip I wanted to share with you guys about the coding interviews is that when you are practicing, try to handwrite the code. Try to not use IDs, because if you handwrite the code, it will boost your confidence in real life interviews as well as whiteboarding sessions. So that one simple tip I wanted to share with you, so it can help you in your interviews. So keep practicing, keep coding, and keep learning different varieties of problems, and click on the bell notification icon so you will not miss any important videos. Share these videos freely, and so other people can also benefit from these videos. And thanks for watching this video.